So you have a quiz tomorrow. Today we are going to go over this. It shouldn't take the whole period. So after I'm done, uh, I'll record this when I'm done. When you can work on your page of notes, which hopefully you're all taking advantage of. If not, that's a personal decision. It's an odd decision, but a personal one nonetheless. So page one is not about equal signs. So I'm going to take this quiz, practice quiz, as if it were a quiz, and the things that I show are what I would expect you to show. So please, if I get to going too fast, just interrupt me. It's okay. I don't mind. And let me know what your questions are. So at page one, there should be no equal signs, no x equals this or x equals this. We're not solving anything in page one. We're just what's matter? Is my TV not on? Is that gonna be a problem? You can't see what I'm doing. Sorry about that. Thanks, Jess. Got her. So what I'm going to do is I'm going to set up the synthetic division. That is all I'm doing in page one. So I'm going to pull the numbers off of my polynomial. Remember, be vigilant to watch for zeros for missing terms. So there's a 1 on the x to the fourth, a negative 11, a 26, a 10, and a 28. And then we are going to synthetically substitute what number? Positive 7. Good. There is no, I'm not going to put a 0 at the end because this page isn't about expecting for this to quote unquote work. This is just, it is what it is. And what we get is what we get. So be very careful with your little tiny calculations. We are all human. We all do make mistakes. We just have to be hyper vigilant and try not to. That's the key. So 7 times 1 is 7. Negative 11 plus 7 is negative 4. 7 times negative 4 is negative 28. Add those, negative 2. Multiply those, negative 14. Add those, negative 4. Multiply those, negative 28. And this one, you happen to get something that has no remainder, which at the end of the day isn't that big of a deal in the context of what we're doing. It just means we have a little bit less writing to do for our answer. So your final answer should be 1 x to the third. Remember, we always start 1 degree less than where we started.
Why is that?
Because this polynomial, my green is hard to see, but do you see my green mark up here? My polynomial starts at level 4. We call that fourth degree. And when you chip 1 degree off of it, and that's what this polynomial is over here, is this is like x to the power of 1. So however many you have, whatever you divide by, you're scraping that many layers off. So 4, 1 layer off becomes 3. Does that answer your question? So it's always with synthetic. When we get to polynomial long division, that just won't be true anymore. Because like if we divide by a cubic, then we'll take 3 layers off, right? So hope that makes sense. So my 1 goes with my x to the third. My negative 4 becomes minus 4, x to the 1 less. My negative 2 becomes minus 2, x to the 1 less. And my negative 4 becomes minus 4 with no x's. That is it. If you add anything else like equals 0, you lose a point. If you try to go further, I'm not interested. We're doing one thing in these problems, and that is just what we did right there. Any questions there? So no remainder just saves us. You know how if there was a remainder, we'd have to put something in that green circle plus a fraction. We just don't have to. So that's it for number 1. Number 2, second verse, same as the first. We're going to go 3, negative 5, negative 9, negative 2, negative 23. And what are we going to synthetically substitute? Positive 3. So the terminology, I don't think it really ever, I don't know if it really matters, but we're dividing by x minus 3, which means we're substituting the value positive 3. So synthetic division and synthetic substitution are kind of this, I mean, they're the same process, but it's just the verbiage. Never mind. So we drop the 3 and we multiply. 3 and 3 make 9. Add those. 4, 3 and 4, 12. Add those. 3, 3 and 3, 9. Add those. 7. Multiply those. 21. And this time we were not so fortunate, right? Again, it's page 1. Going to get remainders sometimes we're not. So again, we're going to begin our quotient with the 3, the first number here that I'm underlining. He leads the way as 3x to the 1 less third, and then we just scaffold our way down to the floor. So it's going to be plus 4x to the 1 less, plus 3x to the 1 less, plus 7 with no x's. And then you're fine to always just put plus here. If you want to get fancy, you can put a minus there and then change the remainder to positive 2. It's safe, though, just to always put plus. No one really cares. So you could just put plus and then put your remainder on top and your divisor on the bottom. Do you have any questions about that? Okay. Yes, sir.
On the last part, since it's a -2, aren't we able to change the sign right after the 7 to be negative?
Mhm.
I should know that.
So, do you think I handled that well? So this plus could become a minus, and then the 2 would no longer look negative. So the minus can take the role or the place of a negativity. What you don't want to do is interpret what I just said as I can change it to a minus and leave this as a negative, because then you've ruined the whole thing, right? Now the overall result is plus, which we don't want. So you choose. I could go either way, as would say, I think any self-respecting math teacher at any level would tell you minus a positive or plus a negative. We're all good either way. So that answer your question? Okay, good. Number 3. I'm going to get my numbers out of here. I'm going to have a 4. And then I just, again, have to be hyper vigilant about checking the scaffolding. Does it work properly down? 6, 5, 4, 3, 2, 1, none. So I don't have to worry about any zeros yet. So 4, 21, 5, -2, -7, +11, -20. And I'm going to synthetically substitute what number? -5. I'm always going to synthetically substitute the number that makes the divisor equal 0. And -5 plus 5 over here is what we're looking for. We're trying to get that. We're forcing that thing to be 0. Okay, so here we go. Drop the 4, -20, add 1, -5, 0. And I put this here on purpose. And you can expect to see this again, that a 0, it's not the end of the world. It's just something you have to be aware of and not slip it. Don't forget that it's there. And then we just continue the algorithm. -5 and 0 makes 0. Add those. -2, multiply 10. Add those. 3, multiply those. Add those, multiply those. And we just happen to get another 0. Whoop-de-doo. So when I write my quotient, the leader, we call this the leading coefficient, is going to be 4. And he'll lead the way with a 4x to the 1 less than he started as, 5. And now we'll just work our way down the ladder till we hit the floor. So the next one is present. It's a 1. So I'm going to have plus 1, x to the 4th. And this is where mistakes can happen. This 0 that I'm underlining in green should not be present in your quotient. He's a skipper. So the next guy down the ladder would be x to the 3. We skip him. There's no x to the 3's. So we skip right ahead to -2x to the next guy in line, which is 2. And we just continue now. So plus 3 to the 1 less, x to the 1 less, -4. And that is that. So be aware of the fact that zeros can be there. They will be there. So I started writing these quizzes that you're going to take tomorrow a couple days ago. And I wanted to give myself time because these things can be a pain to write. That's not really true, but it takes effort to make sure that certain things are happening. And I'm just telling you that zeros will be there and you need to be aware of that. Okay. Any questions on number 3? Okay. Number 4, I have again hit you with a 0, but I put it in a different place this time. This time you'll notice that the scaffolding is off. When you look at your original exponents, they go 10, or excuse me, they go 5, 4, 2. So you can plainly see that right there, there's a void. There's a term that got skipped. So when I'm prepping my synthetic, I need to be aware of that. And my numbers are going to be 10, 24, missing guy, -25, -8, 14. And then what number are we going to synthetically substitute? -2. And we're off. After this, I mean, a 0 is just another number. It's not like we can't handle it. We just have to we have to get it in there as the key. So we're going to begin the process. Drop the 10, multiply, add, multiply, add, multiply, add, multiply, add, multiply. And we do get a remainder this time. And so we're going to have to incorporate that into our answer. Any questions about the process? Okay. The answer then would be, remember, and it says this in the directions, it's always going to be Q plus R over D. Quotient plus remainder over divisor. So 10 is going to lead the way as 10x to the 1 less than he started as. And then we're just going to work our way down. I have to take this, sorry. And we just continue on. We just keep dropping terms. So the next one is plus 4, x to the 1 less, minus 8, x to the 1 less, minus 9, x to the 1 less, plus 10, no x. And then you can put minus 6 over, or you can put plus -6 over x plus 2. Why we drop these numbers down?
Like I know to do it, but I don't know why.
Yeah, I can explain it to you. This may not be the best explanation you've ever gotten, but having been asked this question a few times, the best I could tell you is let's equate it to something you learned in like 5th grade. So if I gave you 24 and I asked you to divide it by 5. So your teachers back in the day would have encouraged you to set it up as 24. Did you remember this remember this from the old days, the old school division? You'll be seeing this again soon, by the way, a little foreshadowing here. You would say, okay, 5 goes into 24 4 times. 4 times 5 is 20, right? And we subtract 24 minus 20 is 4. And you would agree that the green number is the remainder, right? So the way generally that we would have you write an answer like this would be 4 and 4 fifths. Do you agree with that? For real?
Yeah.
Promise? Okay, mixed numbers have always just meant addition. So 4 and 4 fifths. If you had like, if you had a huge party and you ordered like 20 pizzas, and when you woke up the next morning, there was still some pizza on the counter, and you had 4 pizzas and 4 fifths of one pizza, you would agree that you could change your wording to say that you have 4 pizzas plus 4 fifths of one pizza, right? And you would agree, I hope, don't ever agree to be polite, that that is the quotient. That is the remainder. And that is the divisor, right? And there it is, quotient plus remainder over divisor. Did that answer your question? It's a good thing because I could not have answered that question any other way. So there you go. That's why we do what we do. Long division has always been quotient plus remainder over divisor. We just, with mixed numbers, don't always put the plus sign. No, that's a lie. We never put the plus sign, but it's there. Any questions on page 1? So to be clear, again, we are not solving anything. We're never going to use the word solve in page 1. Right? We are dividing. That's all we're doing. This page, we are solving. And so we're going to find all the zeros. And some of the zeros will be rational. Some of them will be irrational. Some of them will be imaginary. Those are the 3 number types that we're going to be exposed to. So we are going to start the process the same way. Synthetically, we're going to set up a division problem of the 3, -13, -15, 25. And then we're going to set it up upside down division sign. And what are we going to synthetically substitute?
Fine.
Thank you. 5. Okay, if it says that f of 5 makes a 0, that means that 5 is a place where the graph does something cool. Or from another perspective, it means that x minus 5 is an evenly dividing factor. But we just use the number that we're given, 5. So we drop the 5. Lie, drop the 3. And here we go again. 5th verse, same as the first 4, right? 5 times 3 is 15, add 2, multiply 10, add -5, multiply -25. And on this page, we're not wrong to expect zeros. So that should guide you through page 2, is that thinking that, my teacher said that this is going to work. I hope he's not lying to me, right? So you can put the 0 early on this page if you want. Now we're going to be left with the numbers 3, 2, and -5, which are 3x squared plus 2x and -5. And this is where, when I'm grading these tomorrow night, I will see a split. I will see, I'm guessing about 75 or 80% of my Algebra 2 students will just immediately dive into the quadratic formula. And then I will see a more sort of, I don't know what's the word I'm looking for, like endeavorous, if that's a word. Some students will dive in and be vigilant about, can I factor? Because if you're good at factoring, you understand that it is always faster. Always. So I'm going to try. And I said this yesterday. The question didn't come from your class, but I did bring it up yesterday, that if you multiply the number in front and the number in back, what do you get? The green numbers. Are there numbers, integers, good numbers, that multiply to make that green number and add to make 2? There are. The fact that those exist means that factoring will work. So in a case like this with 3 and 5 being prime numbers, I'm like, yeah, sign me up for this. So what I keep doing, the way I've formatted this is I found this to be good usable space up over to the right. So I just kind of draw a little arrow and say, I'm moving up this way now to the northeast. And I'm just going to go and factor right now because the little green test told me it's going to work. So I'm going to put a 3x and an x. My equals 0 is now present because I am solving on this page. I'm finding solutions. And I do know that I need a plus and a minus. And if you put a 5, am I doing something crazy here? A 5 here and a 1 here. Yeah, that'll work. And then a plus here and a minus here. You're good to go. So what answer do you get out of this one that I'm underlining in red? X equals what? Go ahead. Watch the board, if you'd be so kind. I'm going to do something and you'll see it. You can't maybe always see my cursor when I'm moving it, but watch what I'm going to scribble out. That's the number that makes kids always say, I forgot how to do these. I forgot how to do these. Pretend that's not there. If it wasn't there, what would you tell me works for the one I have underlined? Obviously, it's -5, right? So the answer is in fact -5, but you have to divide it by the number that's in front of x. So -5/3 is the solution that comes from that one. You'll get fractions when there's a number in front of x. The other one probably requires no explanation. That one is just a simple x equals 1. And I've said this before, and I'll fire off this warning shot today, and I'll fire it off again 5th hour, and I'll fire it off again if you come in for help sometime today. A very common mistake with these problems is to feel pretty dang proud of yourself for that. You're like, boom. But we forget that there was also an answer earlier, right? 5 was given to us from the get-go, so we have to add it to our list of answers. Do not forget the freebie. Your box at the end should contain your solutions, all of them. Any questions about that? Okay. Number 6, we're going to set up our synthetic with 3, 7, -49, -45. We're going to upside down division sign thing. And what are we going to synthetically substitute?
Okay.
-5. And we're going through for the 6th time. Well, I mean, honestly, it's probably the 94th time by now, but in this quiz, it's the 6th time. We're going to drop the 3, multiply, add, multiply, add, multiply, add, surprise, surprise, right? And this time, the quadratic equation that I'm working with is 3 of those, -8 of those, -9 of those. Make sure you add your equals 0 now, because we're solving an equation at this point. If you do the factorability test with the 3 and the -9, what's 3 times -9? -27. Are there good numbers that multiply to make -27 and add to make the number in the middle, -8? No. The closest you could get would be the 3 and the -9. But when you add them, you get -6. And you're like, aye. So that tells us that the quadratic formula is going to be required. So this is the point at which I take a moment and I write down that A is 3, B is -8, and C is -9. And again, I head up here to the northeast and begin my process. So, I mean, I don't know what your notes are going to look like. Different people make different kinds of notes. But if you don't have the quadratic formula in your notes, man, I think that's a little crazy, you know? Not that, I hope you don't forget it because there's a cute little song and stuff, but like, what a shame that would be, right? You'd miss you'd miss a ton of problems on the back page for a really stupid reason. So if you need it, put it back up on the board again at some point, let me know so you can get it transferred correctly. But it starts out by telling me to do the opposite of whatever B is. Don't say negative. It says it in the song, but I would more think of it as the opposite. So that whatever B is, since he's currently -8, not me, man, I'm going to put a +8 plus or minus the square root of a whole bunch of stuff. And I'm going to start by doing B squared, which is always positive. So if you had to use a calculator for -8 squared, which you shouldn't, make sure you don't type in the negative, right? That's 64 minus, I'm actually going to just put plus 4 times 3 times 9. Can I do that? Is that legal? It is. You can change the minus to a plus if you think of the future and know that it's happening anyways. So just kind of get ahead of it. Because the 9 being negative back there at the end is going to cause it to happen anyways. And we're going to divide all of that by AA, which is 6. And at this point, it is okay to use a calculator without any like guilt or shame, because the numbers start to get a little bit big sometimes. So in this case, when you take 64 plus 108, you get 172. So we're currently sitting here looking at x equals 8 plus or minus the square root of 172 divided by 6. And some of you have expressed to me that you have a hard time with breaking down square roots. So I will just remind you of the process. It's okay to grab low-hanging fruit. It'll work. What's something you know this can be divided by? 4. And you just know that because it ends in a 72, and you all, of course, know that 4 times 18 is 72. So going into this, you at least know that 4 is going to work. Let's see what he leaves behind. What's his like leftover trash? What is it again? 43. And I like this because even though 4 was low-hanging fruit, turns out it's the only piece of fruit on the tree. So it's okay to take 4 because 43 is garbage, right? So this becomes now 2 roots of 43. So we're going to go back to the other page now, and where it used to say the square root of 172, I'm going to say, no, 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 I can do better than that. I'm going to write you now as x equals 8 plus or minus 2 roots of 43 divided by 6. And then I still got this nice space over here in which I can now write my answers. So this particular answer is Doritoable. Anytime you get a jailbreak, you want to check the Dorito. It's not a guarantee. Like if the other ones were like, 4 and 6, but you broke out a 5, no good, right? 5's the deal breaker, but the Dorito works a lot. So if you divide all those numbers by 2, they become 4, 1, and 3, which leaves me now with my answers, which are x equals 4 plus or minus root 43, all divided by 3. And I'm telling you again, it's really easy at this point to pat yourself on the back and go, bam, draw a pencil. Got to put a comma and the freebie. Who was the freebie? -5. Good there? Okay. All right. Question 7. Just begin the process the same way. 10, 51, 77, 30. And we're going to divide this. By the way, as I'm sitting here, I was thinking I might put extra credit on the quiz tomorrow. Depending, I've still got a little bit of time I need to invest in constructing the actual quizzes themselves. But I feel like this quiz presents a great opportunity for some extra credit. And the hint that I'll give you the hint in a moment. But I think I'm going to make it happen. What number am I going to put over here on the outside?
Okay.
Mm-hmm. And we begin. And if you struggle with this, you've got 23 hours and 30 minutes to come to me and tell me that. Hey, I'm still not seeing how to do this synthetic stuff with the fractions. I help you. But what I do, I'll drop the 10 first, of course. I just keep using the fishhook thing. So when I'm faced with 3/5 times 10, I'll put the negative now so I don't forget. But you just take the fishhook and you think of it. I'm just going to use up a little space over here. If I ask you to do 3/5 of 10, just always remember the little hook pattern. 10 divided by 5 times 3, right? A little slick trick you can use in math. And if it doesn't work, then you've got to go to plan B, which is then if the fishhook fails. And when would the fishhook fail? It has something to do with this number.
It's
If it doesn't divide into 10, right? So like if this 5 were a 4, then clearly the fishhook would not work because 10 divided by 4 is like, whoa, stepping out, right? That's when you abandon ship and put the 10 over 1 and you just suck it up and get a fraction. I'll tell you straight up right now, if that happens to you on tomorrow's quiz, what I've found in my experience with this is that if a fraction happens in the course of the multiply add pattern, you probably are on the wrong track. You did something wrong somewhere. And it's not a set rule, but usually if it works, it's going to feel good throughout for the record. So anyways, if you do the fishhook, 10 divided by 5 is 2 times 3 is 6. And I've already got the negative, so I don't want to spaz out and forget that. 51 minus 6 is 45. And then again, just do the fishhook. Put the negative before you forget. 45 divided by 5 is 9 times 3 is 27. Add those together, you get 50. Fishhook it again, put the negative so you don't do something stupid. 50 divided by 5 is 10 times 3 is 30, and there's your 0. What numbers make up my quadratic equation? They're these numbers, right? So I'll ask you again, what numbers make up my quadratic equation?
Mr. Ahern, do you have anyone in your class that did not get their picture taken the first time?
Thanks. That took way longer than I wanted it to, but after a couple minutes, thank you for finally hooking me up. The numbers we're looking for are not the numbers necessarily that we see. We would be crazy to not take advantage of making all of our numbers 5 times as small. Like, that'd be nuts. And if you like big numbers and just want to challenge yourself, that's okay. You can use them, but not this guy. So again, I'm going to do the divisibility test because I'm curious. I'm going to take the number in front, which is a 2, and the number in back, which is a positive 10, and I'm going to multiply them. What is 2 times 10? Are there numbers that we like that multiply to make 20 and add to make 9? 5 and 4 is all I needed to hear. The fact that 5 and 4 add to make 9 and multiply to make my green number, to me, puts up a big green flag and says, go. So I am not going to use the quadratic formula. I won't do it. I don't want to use it when I don't have to. Good at it, but it doesn't mean I love using it. So I'm going to head over here now and I'm going to factor. I'm going to use 2 shells. And I'm going to put in a 2x and a 1x and a plus and a plus. And now you just have to tinker with numbers that will multiply to make 10. You're probably thinking of 2 and 5, which makes a lot of sense. If you put the 2 over here, you pair those outer guys up to make 4. You're left with a 5 here. Pair the inner guys up to make 5. And you're like, bam, 4 and 5 make 9. I'm about done. So having said that, from this one that I'm underlining, what answer do we get? X equals what? Nope. Yep. From the second one, what answer do we get? And then again, I hope I have to spend exactly 0 red ink tomorrow night on taking points off because students forgot to bring down the freebie. What else does X equal? Yeah. Still feeling the vibe, the flow? Quick, we're done with 7 problems out of 8. What is that as a percentage? Go.
We're done.
7 out of 8. What is that as a percentage? Do you guys know what 1/8 is as a percentage? Do you guys all know that 1/8 is exactly 1/2 of a fourth? What's a fourth as a percentage? What's half of 25%? So every time someone gives you an eighth of something, like if you have a pizza and the guy or the gal at Domino's cuts it into 8 evenly sized slices, if you have one slice of delicious pizza with like jalapenos and pineapples and pepperoni, if you ate one slice, you ate 12.5%. So every time you add a slice of pizza, you add 12.5%. So let's work our way up the ladder. What's 4 out of 8? That's 50%. Good. What's 5 out of 8? Add another 12.5%. What do you get? 62.5%. Add another 12.5%. What's 6 out of 8? That's 3/4 of the pizza. So since we're at 7/8 of the way done, add another 12.5%. How's that for some good real world sensible mathematics for you, right? So when I do those kinds of things, just because I like to, because it's fun, with eighths, I just work in packets of 12.5. And I know the big ones. I know like a quarter is 25. I know a half is 50. I know 3/4 is 75. And then you can just chuck another 12.5% in at the little intervals along the way. Anyhow, we're 87.5% of the way done with the quiz. Why you? All right, so let's go. So we got 6, 14, -37, and -5. And what are we going to synthetically substitute? I got a lot of questions about this one throughout the day. It's not 5. It is 5/3. And it's the same as I'll always answer the question this way. The thing I just underlined up there in red, what number could you put in place of X to make it equal 0? It's no different than what we would do like at the end of a factoring problem. And if you forget, I would add this to my notes, like, because I want to I want to get 100%. You want to get 100% on everything. That should always be your goal. I would add to my notes, okay, if I forget how to get the red number, 5/3, I take the factor and I just force it to equal what I want. It's one of the most powerful things in mathematics you can do is just set things equal to 0. It accomplishes so many objectives. And then you just solve it like a sixth grader would. You add 5 to both sides and you divide by 3, and you can rediscover how to do that every time on your own if you forget. Okay. So that always works. Anyhow, I digress. Let's go. Drop the 6 and fish hook. You're going to fish hook the next minute of your life away. 6 fish hook divided by 3 is 2 times 5 is 10. Add those, you get 24. Fish hook it. 24 divided by 3 is 8 times 5 is 40. Add them up, you get 3. Fish hook it again. 3 divided by 3 is 1 times 5 is 5. And hey, shocker, you got a 0. So what numbers will I work with for my quadratic equation? 2, 8, and 1. Well played there. So we have 2x squareds plus 8x's plus 1. And not going to lie, I don't think you need a factorability test for this one to just figure out that ain't going to happen. But if you did the factorability test, you'd quickly discover that, nah, no way. So we're going to take these numbers. I'll put a green box around them. Those are going to be the numbers that we're going to plug into our super mega awesome quadratic formula. So the formula will begin up here to the northeast with x equals, and we're off. What goes first? -8. Plus or minus a big, long square root sign. Leave yourself plenty of real estate in that bad boy. B squared. And this time I am not going to do the sign change because there's no negative anywhere that's going to cause the switch. So I'm going to be faithful to -4 blank blank. And that's all divided by AA 4. Who's going in my blanks? A and C. And I really thought I had some imaginary ones on here, so apparently I forgot. I meant to. And so when I was writing this last night, not last night, I think I wrote this on Monday night. Yep. What I had set out to do, I did not accomplish. I wanted the back page to be a little bit more of a sampler platter, and I clearly dropped the ball. So what I was going for was a bit more variety, and what I came up with was a little, I see now, a little bit dry. So I was hoping this one would be imaginary, but looking at it now, I realize, nah, I kind of blew it. So hint, hint, wink, wink. You really ought to expect that you're going to have a negative square root tomorrow. Okay? Okay, good. So the reason I know it's not going to be imaginary is because the numbers in this red box over here that I'm currently making don't make a big enough number to make 64 go negative. What is 4 times 2 times 1?
No.
8, right? I'm going to go with 8. You could do 9 if you want. It's okay. You do you. It's 8. And then what is 64 minus 8? 56. So the current state of my answer is -8 plus or minus the square root of 56, all divided by 4. And then again, we have to go off to the side and prepare the square root. How do you break down the square root of 56? 9 times 6 makes 54. 14 and 4 is the only acceptable answer. You could find other numbers that multiply 56, but the only pair that does me any good is 4 and 14. People sometimes say, but can't you break down 14? And that's when I know, if someone says that, I know I need to work with that person more. Yes, 14 is not prime. I get it. But his factors are trash. 2 and 7 do me no good. So I know that Michaela has found the best possible combination. So I'm going to go back and put in 2 root 14 where the root 56 used to be. So we currently are sitting at x equals -8 plus or minus 2 roots of 14 all over 4. And the Dorito shows himself again, the guacamole Dorito. What can you divide all those guys by? So that becomes a -4. That becomes a 1. becomes a 2. And then it's time to now express our answer. Answers. X equals what? -4, plus or minus. Root 14, all divided by 2. And then before you put a box around that, you're going to put a comma and say that X also equals 5/3. I knew that one at the beginning of the problem. So because I have a couple more minutes, I know you want to be done, but I would be remiss if I didn't add this to the recording. I made reference to this. Be prepared tomorrow that when you get your square root at the end, you might get something like -56. So ready? What is our thinking? What is my thinking when I get a negative square root? What else? I'm not scared. What is my thinking as I go through this process? I need an I, but really what your thinking should be is leave the I for later. Like you should just treat this like a 56, right? So you're still just going to do root 4 and root 14, right? And you're going to get the same answer. You're going to get 2 roots of 14. You just have to be cognizant of the fact that it's imaginary. Acknowledge that by sticking an I right there. So don't let the I thing get you down, right? It just, no big deal. Do you have any questions for me? You guys have a couple few opportunities to get help if you need it, and here they are. I will list them for you. Your first option is flex today. Your second option is lunch today. Your third option would be if you're able or want to stay after school with me today. After that, if I don't see you for another 23 hours and 15 minutes, then the next time I see you, I'll be handing you a quiz. Good, good. Coulter, you good? You going to get 100%?
Right.